In this video, we're going to make Minesweeper in Unity. This is a great game with some simple logic which makes it perfect for beginners to learn. Let's begin! Hello and welcome, I'm your Code Monkey, and this channel is all about helping you learn how to make your own games with in-depth tutorials made by a professional indie game developer. So if you find the video helpful, consider subscribing. Okay, so this is what we want to make. First of all, if you're not familiar with Minesweeper, here's a quick rundown of how the game goes. We have our play area in here, and as you can see, it's using a nice grid. Now hidden under this grid, we have certain mines. The mines are randomly generated, so here we can use a debug visual. This reveals the entire map. And every time we play, we get a different map. So there it is, by reloading the scene, we have a new map, and just like that, a new map. The goal of the game is to clear the entire map without triggering any of the mines. And the way we do that is with the help of mine indicators. Now we can click to explore our map, so I click in here, and there you go, since the position underneath it is a mine indicator, it revealed just that position. In this case, the indicator is a number, and the number means that there's this many mines in the area surrounding this grid position. So there are up to 8 positions total neighboring a grid position, above, below, left, right, and diagonals. But since this one is on the corner, it only has these ones. So in these neighboring positions, there is going to be one possible mine. So in this case, I can use the debug visual and see, yep, indeed, there's that mine in there. So this one has one mine neighboring, and this one has 2, so that one and that one, yep. Then we also have some areas that don't have any neighboring mines, and when we click on those, they show up all of the connected positions without a mine, as you see. And finally, we can right-click in order to place a flag to indicate where we think a mine might be. Then the game ends when either we hit on a mine, so there you go, hit, and there you go, we have a game over and a nice button to retry, so hit retry. And again, we got a new nice map and the timer goes back to 0. And then we can also win, and when I click to win, there you go, it asks me for my player name, so I put in the player name, and my score gets added to a very nice high score table. So just like this, we have our very nice and simple complete game. Alright, so this is our goal, let's get to it. Now, Minesweeper is a game which is played on a grid, so that makes it perfect for us to use our previously made grid map. If you haven't seen that video yet, go check out the link in the description. We created this grid map entirely from scratch. Then we added generics, which lets us hold a custom object type in each grid cell position. So using that as our base, we can really speed up the development for this game. So let's begin by setting up our map. So a new script, this will be our map. Now in here, let's make this a basic class, so no mono behavior. And on the constructor, in here we want to make our grid map. So we define a private grid. And now in here, we need to input our grid object. So let's make that. Back in here, let's make a new C# script. Call this our map grid object. So this is the grid object that is present on every position in our grid. And in here, we're going to make the default fields, just like we did when we created our grid map. Okay, so we have our simple grid object. Now let's go back into the map. And in here, we can now define our grid map as a grid of map grid object. And here on the constructor, we simply instantiate. Okay. Alright, so here's our grid being instantiated. Again, if this seems weird to you, make sure you watch the previous videos on making the grid and making the grid with generics. In here, we are instantiating our grid with a size of 10 by 10. The cell size is 10 units. We're origin on vector 3.0. And we are creating our grid object very simply with the grid, the x, and the y. Okay, so now we need to make the main script that will create our map. So here, let's make a new C# script. Call this the Minesweeper game handler. And let's make a game object to run this script. And we drag the script onto it. Okay. And in here, we simply go into our start and we create a new map. All right, there it is, very simple. Now let's just make sure that on our grid script, that in here we have the debug visuals enabled. So let's set this to true so we can visually see it. All right, let's test. And yep, there it is. We have our grid map being instantiated. And as you can see, every single grid position contains our map grid object. All right, great. So far, so good. Now let's set up our grid object correctly. Based on our game design, we only have a limited number of possible types for each grid position. We can have an empty, a mine, or an indicator. So we're going to represent those different types using an enum. So in here we have a public enum. Let's call this our type. And for the various types, we have empty, we have a mine, then the indicators. Just like that. And finally, we have a type for our current type. Now here on the constructor, let's set our type. So just for testing, let's set it to random. And let's also override our toString and make it return a string of our type. Okay. So let's test, and we should be able to see our grid with random types everywhere. Let's see. And yep, there it is. Our grid does have random types on every grid position. So you can see over here we have a mine, here another mine, here a mine num5, and so on and so forth. All right, great. Now let's make a proper visual instead of using this debug view. Over here I have a class that takes in a grid and instantiates a prefab on each grid position. We first made a grid visual in the heat map video, then we also expanded upon it in the tile map video. So if you've seen both of those videos, you'll be able to easily understand how all of this works. We simply have a setup function, and then we are subscribed to the onGrid object changed event. And when that happens, we call this function, which updates the various prefabs related to every grid position. So we can customize those prefabs in order to fit our game design. So let's first go into the editor to make our visual prefab. Let's make an empty game object. Inside, let's add a sprite. We're going to select the empty background sprite. There it is. Then we're going to have another sprite. This one will be above the background. Let's drag the mine sprite. Okay, like that. And finally, we're also going to have a text object. And we're going to use the text in order to display the number of mines. And now just drag the game object onto the prefabs folder in order to make it a prefab. Okay, so we have the background sprite. Then on top we have an icon sprite. So we can either put the mine or the flag. And then on top we also have the mine indicator text. And finally on top we can also add another sprite for this texture right here. Alright, that's our prefab. Now let's make a game object to run our visual code. Let's put it on 0, 0. And let's drag the grid prefab visual. Okay. And now here you can see that we have a field for the prefab visual. So let's remove this one from the scene, and in here drag our prefab reference. Okay. Now we need to see this working is to call our setup function. So here on the game handler script, let's add a field for our visual script. So here we just need to call our setup and pass in our grid. And finally, let's go into the editor. And here on the game handler, let's pass in the reference to our script. Okay, that should do it. Let's test. And yep, there it is. We can see the grid, and we have a prefab spawned on each grid position. So we can pause and look at the hierarchy, and there it is. We have all of our grid node visuals. All right, awesome. Now with this working, let's set up the display to be based on the underlying enum value. So here on our visual script, here we have the update visual. And in here, we are cycling through every single node position on our grid. We grab the visual node, we set it to active, and then we set it up. So we can go here and do all of our setup. Let's pass in the visual node and as well as the grid object. So now here we can do a simple switch on our map grid object, and we get the grid type. Okay, so here we are grabbing references for all of our elements inside of our visual node transform. Again, here is the prefab, and this is how we set it up. So you have the background, the icon, the indicator, and the hidden sprite. So here, if it's empty, we're going to hide the indicator text, and we're also going to hide the icon. Then in case we have a mine, if we have a mine, then first we hide the text, then we show the icon. Then we have all of our indicators. So for the indicators, we hide the sprite and we show the indicator. So in case we have an indicator, we show the text and then we set the text to the correct number. And for right now, we're not going to deal with revealing, so let's set the hidden transform to always be hidden. Okay, so far so good. This should be working. With this, we should be able to see the correct visuals on each grid position. Let's see. And yep, there it is, we have all of our nice visuals. So over here we have an empty, we have an 8, 7, over here we have some mines, and all of them are working exactly as intended. Great! So right now with the visuals and the underlying objects working, we can finally generate a map. So in our grid object, instead of having a random type, let's start off at empty. Okay, and now let's go into the map constructor. And in here, after we instantiate our grid, let's randomly place some mines. Alright, so we are going through this cycle 10 times, and we're simply randomizing the x and the y. Then we get the grid object on that x and y position, and we set the grid type to be a mine. So just like this, we should have randomly placed 10 mines. Let's test. And yep, there it is, we have some random mines. Let's reload. And there you go, they're on a different position. Try again. And yep, another random position. Awesome, so our randomness is working correctly. However, we do have a slight issue. We're placing the mines randomly and we're counting up to 10. However, this script is completely random, so we might be overriding a mine, so at the end we might not actually end up with 10 mines. In here, for example, you can see 1, 2, 3, 4, 5, 6, 7, and only 8 mines. So let's make sure that we always set the exact number of mines that we want. So here we get the grid object, then we do if the map grid object, we get the grid type. If it is not a mine, then we set it and increase the counter. And if it is already a mine, then we're simply going to go again. So let's see now. And yep, there it is, we have our random mines in our map, and we can place an exact number. Okay, great. Now, after we place our mine, it's time to place the indicators. So here we are placing all the mines, okay, and then afterwards, let's cycle through the whole map. So we are cycling through the width and height, and we check if this is an empty position. If it is an empty position, then we want to calculate how many neighbors we have with a mine. So let's make a function to get those neighbors. Alright, so here we have a function to get all of the neighbors of a certain x and y position. And we're simply doing some checks to make sure that the numbers are valid. So we make sure that the x minus 1 is above 0 and below the width, and so on and so forth. So we get the left, left down, up, right, so on and so forth. Okay, so we have this function to get our neighbors. Now we can go up here and get our list of neighbors. And here we define an int for the mine count. We start off at 0, then we cycle through all of the neighbors. And if the neighbor grid type equals a mine, then we're going to increase the mine count. And after going through all the neighbors, then we can now do a switch on our mine count. To switch on the mine count, and based on how many we have, we set our correct map grid object type. Right, great. So with this, let's test and see our mine indicators. And okay, there it is, and everything seems filled. Let's see if it's correct. So for example, on this corner, we have a mine, and yep, it is correct. Empty, empty, an indicator, indicator, and we got a mine here. This one says we have 2 mines, and yep, we have these 2. This one says 3, 1, 2, 3, and yep, all of them appear to be correct. So in here we have a 3, so 1, 2, 3. Here we have a 2, 1, 2, and so on. All right, so our algorithm is working correctly. And again, this is all being created dynamically, so if we run this code again, there it is, we get a completely different map, and again, the algorithm still works. So this one has 2, so 1, 2, another 2, 1, 2, and so on. And there you go, as you can see, the algorithm is working correctly. All right, awesome. Now let's quickly try this out with more mines. So here, instead of generating 10 mines, let's try putting 30. Let's see. And yep, there it is. We have our map full of mines. And now let's see. So this one has 2, 1, 2. Yep, that's correct. This one has 4, 1, 2, 3, 4. This one has 5, 1, 2, 3, 4, 5. All right, awesome. So we have the indicators correctly displaying how many mines surround them. So we have pretty much our map generation correctly working. Now let's deal with player input. So let's go into the game handler. And in here, let's make a private void update. And on update, let's test for the mouse button down. And if we have the left mouse button down, then we're going to tell the map to reveal the grid position on this world position. So let's grab the world position. So here I'm using a function from the utilities in order to get the mouse world position. As always, you can download the utilities for free from unitycodemonkey.com. Here is the function in case you want to implement it yourself. All it does is it takes the world camera and does a screen to world point on the screen position. Okay, so with this, let's go to the map and we're going to make a function. Let's call it reveal grid position. And let's pass in our world position. Okay. So here, let's make that function. Down here, a public void reveal grid position, and we receive a vector3 for the world position. And we are going to grab the map grid object. So we have the grid object underneath our world position. Now we want to reveal it. So to do that, let's go into our grid object definition. And in here, let's also add a boolean called isRevealed. By default, it's not revealed, so let's put it to false. And let's make a function to reveal it. We simply set it to true. And again, due to the way that we created our grid, we need to go into grid and call trigger grid object changed, passing this X and Y. So this allows us to fire the event, so we can then update our visual. And again, back into our setup visual node. Now we can deal with our hidden transform. So if the map grid object dot is revealed, so let's make this. Just in here, a public bool is revealed, and we simply return our boolean. Okay, so if it is revealed, then we do all this. And if not, then the node is hidden. So all we're going to do is set the hidden transform to visible. All right, that's it. Very simple. So let's review how our code is running. Over here, we have our main game handler script. We are testing for an input on the mouse button down. So when we click with the mouse button, we call the function to reveal the grid position, and we pass in the world position. Then the map gets the map grid object underneath that world position, and we're going to call the reveal function. So that reveal function is on the grid object. And over here, all we're doing is setting this boolean to true. And then we fire the event on our grid. When we fire that event, the visual captures that event and calls the function in here to update the visual, which calls the setup visual node. And then in here, we set up this visual node. We ask if it's revealed. If so, then we show it like we were doing previously. And if not, we simply show the hidden transform. Okay, so let's test. And yep, for starters, everything is completely hidden. Now let's put the mouse here and click. And there you go, that position was revealed. Now click some more, and there you go, that one is revealed, and down, 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 down. So for example, click here, and that's a mine, click there. Okay, let's see a indicator, there you go, a 2. So that means there's 2 mines within these 8 positions. Let's see which one it is. That one has a 1, so there's a mine here, 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 or here. And it's probably in here, and nope, it's not. This one has a 2, so there's 1 here, and so on. And there you go, just by clicking, we can now uncover our map. Awesome. So now the next step is to identify what we actually clicked on. So for example, if I click on a mine, we should be able to get a nice game over. So over here on the map, on the reveal grid position, let's make this return a map grid object type. And we go into that one, we reveal it, and we return the grid object type in there. Okay, so now we can go into the game handler. And in here we reveal it, okay, and this will return a map grid object type. And then with this type, we can simply test if this one is a mine. So if we hit a mine, we're going to spawn a pop-up saying game over. All right, so let's see if this happens whenever we reveal a mine. Okay, here we are, let's reveal. And nope, that's empty. Empty, empty. Okay, there's a 1, so there's a mine at some point in here. And there you go, that's our mine, and we have our nice game over pop-up. All right, great. So we are now correctly identifying what we reveal when we reveal a position in our grid map. Now let's just make a quick debug visual to show the entire world so we can easily test clicking on different objects. So over here in our visual script, let's make a boolean and a couple of functions. So we're going to have a private bool. Let's call this reveal entire map. And let's also make a function. Okay, so we can set this boolean. And now here in our cycle, when we go through the setup visual node, let's see if this one is revealed or we are supposed to reveal the entire map. And now let's go into the game handler. And here let's add some debug keys. Okay, so here on key down, when I press the T key, we're going to reveal the entire map. When I let go, it's going to go back to normal. Okay, so let's test. Okay, here we are with everything nice and hidden. Press T, and there you go. I can reveal the whole map and let go, and it goes back to normal. So this is excellent for us to easily test what's going on under our map. So for example, I can see there's a bomb here. So now I'm going to click, and there you go, instant game over. So in here we got a 3, and there you go. All right, so this is very useful for testing. Now let's handle the logic for revealing an empty position. When we do that, for example, in this position, when I click on it, it should reveal that one, but also every other empty position that is surrounding it. So let's add that logic on our map. Over here in the map, let's go into the reveal grid position. Okay. So we are revealing a grid position. Now let's test if this one is an empty position. So if this one is an empty, then we want to reveal all of the nodes that are connected that are not mines. Okay, so we reveal the current grid object under the worm position. So we get that one on the worm position. We call this function with our grid object. We call it to reveal. Then we test if it's an empty. Then we cycle through all the neighbors, check if they are not mines, and if not, then we reveal them. However, with this, we are going to have infinite recursion. So we need to keep track of which nodes we've already revealed. Okay, so here's the algorithm for revealing all of our connected nodes. So we start off just revealing this object, then we check if it's an empty grid object. If so, then we want to reveal all of our connected nodes. So we set up two lists to keep track of the ones already checked and the ones that we need to check. So we first add to the queue this current map grid object, and then we have our cycle where we're going to run whilst we have nodes to check. We grab the first one, remove it from the queue, add it to the already checked, then we check the neighbors. Then we test the neighbors from that grid object. If it's not a mine, then we reveal it. And then we check if it's an empty. And if so, then we add it to the queue, which will then run, and so on and so forth. So with this, we should be able to reveal all of our connected neighbors when we click on an empty node. Let's test. All right, so in here we can use our debug view. Okay, so we can see that over here we have a whole bunch of empty nodes. So when I click in here, it should reveal this one, all of these, and also the number ones connected. So let's see, and click in here, and there you go, it revealed all of the connected empty nodes and number nodes, exactly as intended. Awesome. So let's try this one on this side, and we click, and there you go, it reveals all of them. So it stops when it finds a mine, or when it finds a number past another number. So it only keeps going for the connected ones, whilst the current node is empty. So just like this, we already have a lot of our game working. We can click to reveal positions, and we have all of our map generation correctly working, so we spawn a bunch of mines and they correctly indicate how many mines are surrounding it. Alright, awesome. Now let's add our mine flag feature. Flags are a way for the player to place a marker where he thinks there might be a mine. They don't actually do anything in terms of game design, they are merely a visual object. So it's actually very simple to add. Let's go in here to our grid object, and let's add another boolean, simply called isFlagged. Let's make some functions to set this value. All right, we have our two functions, okay. Now let's go into the visual, and in here on our visual node, if the node is still hidden, we show the hidden transform, okay. But then let's also go into the map grid object and test if it is flagged. And if so, then we want to show our flag. So you go into the icon sprite renderer, and we're going to set the sprite. So now we need a reference to the flag sprite. So up here, let's add another serialized field. Okay, we have a flag sprite and a mine sprite. So if it is flagged, then we set the sprite to the flag sprite, and then in here, in case we modify that one, then we need to set it back into the mine sprite. All right, so just like this. Now we can go into the Minesweeper game handler, and in here we're testing on left mouse button to reveal, okay. And now let's also test for the right mouse button. So on the right mouse button, we want to flag our current worm position. So let's make that function on the map. And all we do is go into the map grid object and call set flag. Okay, so that should do it. Let's see if we can see the visuals. Okay, here we are. Now when I right click, and there you go, this position has been flagged. Again, this really is just a visual mechanic, so if I left click, I can still reveal it. So the goal with this mechanic is, for example, over here in the corner, you can see a 1. So there's a mine connected to it. So it's not on this one or this one, so there has to be a mine here. And if we use the debug, we can see, yep, indeed, there's a mine in there. So in this case, the player would flag it in order to know, okay, there's a mine in there, so don't reveal it. That's the goal for this mechanic. Okay, so all of our player actions are already implemented. All that's left is to handle game over and game win states. Now we already identified game over, so if I click in this one, there you go, we got our pop-up. So now let's deal with the game win. Now the player wins the game when all the nodes have been revealed except for the mines. So let's deal with that logic. Here on the map, after we reveal a certain position, let's make a function to test if the entire map is already revealed. Alright, so here we have our code. We cycle through the entire grid. We check if it's not a mine, and if it's not a mine, we check if it's not revealed, and if not revealed, then we return false. Otherwise, if we go through this entire cycle, then the entire map is revealed. Okay, so here after we reveal, let's call this function. And if the entire map is revealed, let's fire an event. So let's go all the way up here to make our nice event. Okay, so if the entire map is revealed, we're going to fire off this event. So now let's go to the game handler. And in here, let's subscribe to that event. So the map.onEntireMap revealed, we subscribe to it. And if so, let's do a nice pop-up. All right, the logic should be working. Let's test. Okay, so here we are. Now let's first check out the Unloose scenario. So we can use the debug. Okay, there's a mine here. Let's check our Unloose, click, and there you go. There's a nice pop-up saying game over. Okay, now let's refresh. Now let's use the debug. Okay, and let's reveal all of it. All right, so using the debug, I can see that this is the only one left. So when I click, there you go, we have the game win event fired. All right, awesome. So all of our logic is correctly working and we can test for game win and game lose. Okay, now let's make a simple game over and game win window. Okay, so here we have a nice game over window, just says game over and a retry button. Now let's make the script. Okay, so we simply have the retry button going into the scene manager and calling load scene. Now for this to work, we need to go into the build options. Over here, we need to make sure we add this scene, okay. And now in here, in order to show and hide this window, let's make some static functions. Okay, here we have a simple singleton with show and hide functions. And now we can go into the game handler. And in here, when we have our game over, let's simply go into the UI game over, grab the instance, and call show. All right, let's test. Okay, here we are. Now let's use the debug to make sure that we lose. Okay, there's the mine there. Now when I click, there you go, we got the pop-up and we got the game over window. So let's click retry, and there you go, we reload the current scene and we can play again. So let's see, clean this one, and boom, there you go, game over and retry, and there it is, and we have a nice new map. All right, awesome. Now that we have the game over working, let's deal with the win state. So when we win, we want to input our time into a high score table. So first, let's count the time. Okay, here we have a nice text field. Now let's go to the game handler. And here let's handle the timer while the game is active. Alright, so here it is, very simple. Whilst the game is active, we simply increase the timer and we update the text. And there it is, and you can see the seconds counting up. Okay, great. Now when we win, we want to show a text input window. Okay, here is a nice input window. Now this window was fully created in a previous video, so go check the link in the description to see how this was made. Over here is the input window script, and as you can see we have various buttons, various actions, and we can essentially call a function in order to show it. So let's use this. Here when the player wins, let's first get the current time. So we're just going to forward the timer to get the time score. Then we're going to go into the input window and call show. We're going to ask the player for a player name. Okay, so we ask for a player name with 3 characters, only of uppercase. If the player cancels, let's simply retry. So you simply load the scene just like previously, okay. And if the player hits okay, then we want to submit that player name and the score into a high score table. Here is the high score table, which again, this was fully created in the previous video, so go check that video out to see this whole thing created from scratch. Here is the high score table script, and we have a nice function to set a new high score entry, so let's use this. So we simply go into the high score, and we simply call add high score entry, and we're going to pass in our time score and our newly received player name. And finally, let's duplicate the game over window in order to make a play again window. Okay, so here we are, and everything so far looks correct. We have the timer increasing and we have our grid. Now let's win the game. Okay, so I just have to reveal this one and we should be able to win, so let's click. And there it is, it's asking for our player name. Let's put ABC and click. And there you go, we have our high score table with our score added right here at the bottom. So we just need to polish this up and reverse the order. Let's do that. Okay, so here we are, and let's try to win. So let's use the debug in order to clear all of this up. All right, when I click here, I should win, so click. And there you go, I won. Now I got the player name, I input. And there you go, the player name is added into the high score table, and as you can see, it is now correctly sorted. So I'm number 1 with a score of 23 seconds. So just like this, we have the save scores, and we also have the play again button. And there you go, we click play again, and it reloads our scene, which reloads with a completely new map. Okay, so now let's just polish this up a bit. First, let's make the bombs be revealed on loose. Okay, so when we lose, we're calling reveal the entire map. And all it does is exactly that. It goes through the entire grid map and reveals every single grid object. Let's see. Okay, so let's click on this bomb and see what happens. And there you go, we have the entire map being revealed as our game over window shows up. So hit retry and see there's a bomb in here. Click, and yep, there you go, we can see the entire map. All right, great. So just like this, we have our completed final game. We have a grid with randomly generated mines. We can use our debug visual to reveal the underlying map to see how the generation is working. So here's another map, there you go. And here's another one, and yep, our map is constantly being generated randomly. So we can play, which means we can click to reveal a single position, so click. If it's an indicator, it just shows that position. However, we can also reveal an empty position, and if we do, there you go, it reveals all of the connected positions. And we can also right click to flag potential mines. So this one has a mine neighboring it, so the mine has to be here. So just like that, we have a nice visual flag. Then if we happen to hit a mine, so I click, there you go, we have the game over and it shows the entire map, and we can easily restart. However, if we successfully clear the whole map, just like this, there you go, we win, and we can now do a player name, give in a player, and there you go, we get added to the nice high score table. So just like this, we have a very nice completed simple minigame. As always, you can download the project files and utilities from unitycodemonkey.com. Subscribe to the channel for more Unity tutorials, post any questions you have in the comments, and I'll see you next time.